We have booster ignition and liftoff of Columbia, reaching new heights for women in X-ray astronomy.
The main thing Chandra does is take these superb, sharp images.
You have done well, my apprentice.
Good afternoon to each and everyone. This afternoon, we are going to discuss about the galaxy. And the subtopic under the galaxy are the extragalactic and galactic astronomy, the extragalactic visual scale, the expanding universe, the types of galaxies, and the properties of galaxies. So first, let's discuss about the galaxy. Galaxy is a massive gravitational bound system that consists of stars and stellar bodies, and other stellar medium gas and dust, and that important but poorly understood component in category the dark matter. Extragalactic or galactic. Extragalactic is a branch of astronomy concerning objects outside our Milky Way galaxy. In other words, it is a study of astronomical objects which is not covered by the galactic astronomy. The catalog of nebula. One of the earliest catalogs of nebulous appearing objects was prepared in 1781 by the French astronomer Charles Messier. Messier was a comet hunter and he made a list of 150 nebulous objects that might be mistaken for comets. Messier list contains some of the most conspicuous star clusters, nebulae, and galaxies. 15,000 nebulae have been cataloged and described. Some have been correctly identified as a star cluster, and other gaseous nebulae such as the Orion Nebula. It's Hubble. Working with 100 inches or 2.5 meter telescope at the Mount Curtin Observatory, he analyzed the light curve of variables he had discovered in 31, in 33, and the angie 6822, and that they were referred as a CHMSC. CHMSC is a member of class rotating variable stars. They are large and hot stars of spectral class H6K4 that are 5 to 20 times as massive as the Sun and up to 3,000 times more luminous due to their high luminosity. Particle secrets may be visible from great distances.
The accuracy of extragalactic distances. These are the list and the type of galaxies for which each of the techniques described here is useful, the range of distances over which the technique can be applied, and the reliability of the distance estimates derived with each technique.
You gotta help me out.
Are moving away from us. This apparent expansion of everything away from us has many applications to the structure and history of the universe. First, let's talk about the evidence of the first observation. The universe expands. This fundamental observation underlies all the modern cosmology thought. In 1994, Percival Lowell established an observatory in Flagstaff, Arizona, to study the planets and to search for life in the universe. Again, to search a life in the universe. Lowell thought that the spiral nebula might be solar systems in the process of fermentation. Therefore, he asked one of the observers, or an astronomer who is best to any report, to photograph the spectra of the spectral nebula to see if the electrolytes suggest chemical composition that is expected for the formation planets. Local observatory's major instrument was a 24 inches refractive telescope, which was not yet suited to the situation of space spiral nebula. And this goes to the Hubble's law. The profound application of Newton's work became apparent only during the 1920s, when Hubble found ways of estimating the distance of the spiral nebula. Hubble carried out the key observation in collaboration with the remarkable men Newton and Mason. Newton began his astronomical career by driving milkshake at the Trail Mount Wilson. He made such remarks that he became a full astronomer at the observatory. In the late 1980s, Newton was collaborated with Hubble by studying the spectra of space galaxies with the 100-inch telescope. When they compared the distance and velocity of both galaxies, they found that the most distant galaxies have the highest velocity of acceleration. Their law of redshift, now known as Hubble's law, established that the velocity of distant galaxies are proportional to their distance from us. Right in a sun equation, the Hubble law is V equals h times v, where v is the decision space, and as v is the distance and h the number of the Hubble's constant. Because of the decision procedure, as the shifts the galaxy strike the line toward the higher wavelength, the Hubble line or law is also called the law of redshift. And the next one is the classification of galaxies. Of the natural classification scheme, we have eight suggested for galaxies. One of the earliest and simplest and the most used today was invented by Hubble during his study of galaxies in 1920s. Hubble trees consists of three spherical classification of regions: elliptical, spiral, and spiral galaxies.
When I find out what went on, I'll bring it back, but it won't be easy. They won't believe how a man could drown in a starseed.
Traveler from Qatar?
Yes, it's me by my father.
Well, nice to be here. Is there some places where we can find a beautiful view of Qatar?
Yes, come with me.
Let's go.
This is one of the most beautiful places here in Qatar. You look at the mountain. It's very beautiful.
Hey, look! Donna, it looks like a spiral.
Spiral. Don't you know that there are three types of galaxies? One is the spiral galaxy, second is the elliptical, and the third is the irregular galaxy. Majority of optically bright galaxies are fall into two general classes, the spiral and elliptical. A minority are classified as irregular, containing both young and old stars. Perhaps a third or more of spiral galaxies display conspicuous bars running through their nuclei. The spiral arms of such a system usually begin from the ends of the bar rather than winding out directly from the nucleus. These are called barred spirals. Spiral galaxies range in diameter from about 6,000 to more than 30,000 pc, and the atomic hydrogen in the disk often extends to far great diameters. From the limited observational data available, their masses are estimated to range from 10 to the 9th power to 10 to the 11th power times the mass of the Sun. The absolute magnitudes of the most spiral falls in the range -15 to -22.5, corresponding to luminosities of about 10 to the 8th power to 10 to the 11th luminosities.
Elliptical galaxies.
Elliptical galaxies are spherical or ellipsoidal systems that consist almost entirely of old stars. They contain no trace of spiral arms. Their light is dominated by red stars, and in this respect, ellipticals resemble the nuclear bulge and hollow components of spiral galaxies. Dust and emission nebulae are not conspicuous in elliptical galaxies, but elliptical galaxies are not devoid of interstellar matter. Many contain narrow lanes of absorbing dust, and X-ray data indicate that 1 to 2% of total mass of ellipticals may be in the form of gas at a temperature that exceeds 1,000,000 degrees.
But how about the irregular galaxies?
Actually, 25% of all galaxies fall into the class of irregular galaxies. It includes a wide variety of size and shape. Like that, you cannot distinguish the shapes or figures of that space.
Which means that sky falls into an irregular shape.
Yes, exactly. But,
What a great place here.
but it's getting hot here. Can we go home and find some drink?
Sure.
Yes.
Did you know that galaxies don't like to be alone? It's not that galaxies feel a social need to congregate with others. Rather, it's their gravitational pull, even across the vast distances of space, that can cause galaxies to form clusters that can contain hundreds or even thousands of individual galaxies. Clusters of galaxies are, in fact, the largest structures in the universe that are held together by gravity. Because of their immense size and mass, galaxy clusters are extremely useful as tools to probe a variety of questions about the universe as a whole, as well as properties of the clusters themselves. Dr. Christine Jones of the Chandra X-ray Center discusses the importance of galaxy clusters and the wide range of astrophysical topics they can address.
Since clusters are so large and so massive, they're a great place to take an inventory of the mass in the universe. In particular, how much is luminous matter and how much is dark matter. We also can study the individual galaxies and clusters and learn what kind of galaxies live in different environments, and how the galaxies, which are often moving in the cluster at speeds of 1,000 kilometers a second, interact both with each other and with the cluster gas. In addition to being massive, clusters are so luminous that they can be observed back to when the universe was only half its present age. Comparing the properties of distant clusters with nearby ones allows us to see both how clusters grow over time as smaller clusters fall into them,
Hey, look, Dona. It looks like a spiral.
Angie, are you there?
Hey, look, Dona. It looks like a spiral.
Spiral! Don't you know that there are 3 types of